Hello everyone, this is Arpit from Algorency and welcome to the linked list lecture of the Algorency data structure video series. In the last video, we discussed the definition of matrices, what they are and how they work. If you haven't seen that video yet, I encourage you to go check it out. The link to the video is in the description box below. Today's topic, linked list, is a fairly easy topic to understand and get started with, but can get pretty tricky as we dive into some complex cases. Even in those cases, it is mostly about handling all the edge cases, so try and keep an open mind here. And I promise it will all make sense in the end. A linked list is a linear data structure in which the elements are not stored at contiguous memory locations like arrays. The elements in a linked list are linked using pointers. If you're using or working with C or C++ and reference variables if others like Python and JavaScript. Well, what does this mean? Imagine a small locality where all the members of a book club live. You want all the details of the people in the book club to write it in your annual school report. But the thing is, you only have the address of the head of the book club. You go to her house, take her details, and then ask her for the address of the next person in the book club. She gives you the address, and now you get there and repeat the process until you get to a person who does not have an address for the next person. Which means all the people in the book club now have been visited by you. Similarly, in a linked list, we initially only have the address of the head of our linked list and we iterate over the linked list in a very similar fashion. Each node of a linked list is at a random place in the memory and each node provides us the address of the next node and so on. Usually, each node of the linked list has two components, a value component and an address component. Value is what data that node of the linked list holds. An address tells us the location of the next node in the linked list. We can traverse the linked list by asking each node the address of the next node until one node has no location in the address section. This is how a linked list is visualized as. Each node is a box with two sections in it. First section having the value of the node and the second section having the address of the next node. In our programs, we usually have one reference to the head of our linked list. This is what we call a singlet linked list. There are other types of linked lists too. This is what we call a doubly linked list. Each node is a box with three sections in it. The first section having the address of the previous node, second section that has the value, and the third section that has the address of the next node. The previous section of the head node is usually empty. As we know, it is the first node in the linked list, so there are no nodes before it. Uses of linked lists. Linked lists can be used as dynamic lists if we have a lot of removal and insertion in the list, as it does most of the operation in constant time. It can also be used as a stack by inserting and deleting both from the head in constant time and following the LIFO property. It can also be used as a queue by inserting on the head and deleting from the tail in constant time and following the FIFO property. Time complexities of linked lists. Some operations in a linked list are constant time, like insertion at head or tail, deletion at the same, while some operations have linear or constant time complexity based on the type of the linked list. Deletion of a middle node is linear time in a singly linked list, whereas it is constant time in a doubly linked list. It is the same with insertion in the middle of a linked list too. There are a lot of ways to implement a linked list, as it is an abstract data type, but this is what I feel is the easiest. A class with the name node with two properties in it. A value property, which we will take as an argument in the constructor, and a next pointer property, which we will set by default to none. You can initialize the head of a linked list in a variable like this. Head equals node 12. and then create a new node like this, temp1 equals node 76, and you can set it to be the next node of the head by writing this, head.next equals temp1. Similarly, repeat the process like this, which will result in creating a linked list that looks something like this. You can also do this iteratively, but that is something I'll let you do yourself as an exercise. Linked lists are far from over now, but this is it for this video. In the next video, we will learn how to perform different operations like deletion, insertion, etc. Like if you liked the video, subscribe if you want more of such content, and for feedback and doubts, use the comment section. Thank you for watching guys. I'll see you in the next video.